Hello, my name is Rhys Coombs and I'm one of the co-founders of CC Hydrodynamics. We're a small UK consultancy specialising in large domain hydraulics and flooding. Today I'd like to show you some of the innovative technology we've been developing which will enable developers to minimise their excavation requirements when looking at flood storage compensation. To clarify, this is a new product we will offer that specifically optimises the planning of flood storage compensation. But first, we should discuss exactly what we mean when we say flood storage compensation. Let's say that your development site lies within a valley. There will usually be a watercourse here. In large rainfall events, this will be prone to flooding from surface runoff. The depth of this varies from river to river and also depends upon the event. Typically in the UK, the flooding of most concern will be the 1 in 100 year event, which we then conservatively scale up to account for long-term climate change. Let's say that your proposed development lies within this floodplain, and to protect your buildings you'll most likely want to incorporate some groundworks to bring areas of your site above the estimated flood level. This prevents buildings from being flooded on a regular basis. However, in doing so you will be actively reducing the flood storage at different levels in this area of the valley. In the UK, this analysis is usually undertaken in 200mm slices. In order to ensure that the site has no significant negative impact on flooding to other stakeholders, both upstream and downstream, you would need to mitigate for the loss at different levels, since these correspond to flooding depths in lower order events. The way that you do this is to plan flood storage compensation. This usually takes the form of a cut and fill excavation plan. This is planned in such a way that no slice below the target flood level sees a net loss of storage. Ideally, you would also look to minimise the excavation volumes which did not help meet these requirements, for example slopes and overlying materials. While this may sound relatively straightforward, developing an excavation plan can be an incredibly time-intensive activity. This is because of a range of factors, including but not limited to 1. Being able to excavate anywhere within your site boundary. 2. Making sure that the planned excavations don't impact on any areas you want left alone. 3. Considering slopes from cutting areas that can be worked to safely. 4. Whether you would be happy to spread the excavation around the site, or whether you would rather work in only a single area. 5. Whether you would like a certain amount of fill material for other areas of your site, which may impact on your decision-making process. 6. Alternatively, whether you would like to minimise the cutting volume to ensure that you do not produce a lot of excess soils and waste materials which would then need to be disposed of. And finally 7. The excavated areas must be demonstrably hydraulically continuous, which means that the slice must be able to fill and drain from increasing and decreasing water levels in the river respectively. With these constraints, there is an exceptionally large number of potential excavation plans for any given site. Typically, consultants will focus on a handful of options, and that the cost of their work will be based on the number of options to be considered. Our innovation, and the reason for this video, is that we've developed a holistic mathematical and computational approach to find the optimal excavation plan for your site. Let's discuss a hypothetical example with some 3D renders. Here we can see a proposed site on a three-dimensional render of a ground model. This is generally built using LiDAR information where it is available, but can be generated from bespoke topographical surveys where they've been undertaken. Due to the nature of storage models, we typically work on a 1 meter grid. The site outline is given by the red boundary, and some areas that the developer has stated he would like to remain untouched are outlined in blue. We can also clearly see that the site is next to a fairly major watercourse. The climate change adjusted 1 in 100 year flood level is shown here in light blue. Clearly a large part of the site is susceptible to flooding, and that the site has a significant amount of flood storage at different levels. On discussion with the developer, they indicate that whilst most of the planned development lies above this level, they would like to raise an area to increase the size of their development. They provide us with a plan and a ground model, and we can see the effect of that here. In this case, we are losing some flood storage at the upstream part of the site. This will need to be compensated for elsewhere. In the first stage of investigation, we will first need to establish what storage will be lost. This image shows a different view of the planned groundworks. We can see that most of this will impact on the flood storage in some way. Using the existing scenario ground model and the developer's proposed scenario ground model, we have established that of our 200mm slices below the flood level, 3 are seriously impacted by the proposed groundworks. We will need to provide 32 cubic meters of storage close to the existing water level, and over 1,000 cubic meters in total over 3 layers. It is at this point that some decisions need to be made by the developer about how they would like us to proceed, since these decisions will impact on the optimization algorithm. For this project, we would need the following information. 1. The side slopes they would like to work to when excavating. We have shown 1 on 4 in this example, but with clever use of gabion baskets and other geotechnical retaining structures, a steeper slope might be possible. 2. The tolerance of the assessment. A large tolerance will lead to a design which conservatively plans additional flood storage. The developer knows that it is a large volume that needs to be compensated and decides on a lower tolerance. 3. The developer's contractor has said that they can reliably work with 5 cm scrapes when they use their excavators. 4. Obviously, we need to tell the algorithm the depth of the slices we need to work to. Sometimes it might be desirable to use shallower slices, say 10 cm. 5. The algorithm then needs to look at patches of ground. The contractor says that for setting out purposes, using 5 by 5 meter areas would be feasible. And finally, 6. The developer, conscious of the density of his proposed development, states that they would like to excavate in only 2 areas of the site. They consider this to be important as widespread excavation could impact on the phasing of the construction works. Following this, CC Hydrodynamics would input the necessary data into our algorithm. We take the stage 1 results, that is, the storage required in each slice and the definition of those slices, and also the ground model and spatial data supplied by the developer. With this information and some detailed OS mapping data, the algorithm will establish the areas that are hydraulically continuous, and start looking for the optimal solution to minimizing the excavated materials, while also avoiding areas of the site that the developer says shouldn't be modified. Using our own software suite and tools, we look at 600 potential nucleation points around their site, and grow an option from each one of these, ending up with thousands of permutations of compensation storage schemes. We select the most efficient of these, and agree with the developer which we should produce the final excavation plan for. This is shown in green and yellow. Following this, we provide the information in GIS and PDF formats for use in their planning application. This 3-dimensional render shows the new area of flood storage provided next to the hands-off areas of the site. Of course, this was a hypothetical example, but if you have a similar issue with your plan development or works, please be sure to get in touch. At CC Hydrodynamics, we believe our pricing should be transparent and easy to understand. The following pricing is only valid in 2019 and assumes that a digital development plan or ground model is available and that the flood level is known. Should these be available, we can quickly establish your compensation requirements for £150 excluding VAT. Terms and conditions apply. To determine your excavation plan in Stage 2, we would first need to know your compensation requirements. For most consultancies, this task is a largely manual process. To undertake the hypothetical example, looking at hundreds of potential options in a short time frame and within a reasonable budget would not be feasible. Please remember when considering these prices that our product provides an optimized plan, which ultimately could reduce the price of your planned groundworks significantly. Instead of offering a time-based consultancy fee, we instead offer this service based on the compensation requirements. For our hypothetical example, the compensation requirements were 1,065 cubic meters. This means that the optimized excavation plan could have been determined for less than £1,500 excluding VAT. This ultimately could have saved the developer a large amount of money, since the planned excavation was significantly lower volume than it otherwise might have been. For small sites, or those sites with low compensation requirements, we have a minimum fee of £600 excluding VAT. If you have already established the flood storage compensation that will be required, then you can use these displayed values to determine an approximate cost of our services. As previously mentioned, these values will be valid in 2019 and subject to various terms and conditions. The proposed prices here assume that you have detailed information about your development in digital formats, such as CAD or GIS. For sites with exceptional requirements, we can significantly reduce the unit price of the assessment technique. As always, if you're unsure, please get in touch with us and we can discuss your requirements. Thank you for listening. If you would like to get in touch, please don't hesitate to contact us on LinkedIn or other social media platforms, or instead directly email us at info@cc-hydro.com. Other ways to get in touch with us are available on our website, which is www.cc-hydro.com.